Welcome back to physics. Now we are going to start learning about electricity. So we're going to start out with just the basics. Electrical charges have two states, positive and negative. The unit for charge is called a coulomb, and you will see that abbreviated with a capital C. And then the symbol for charge is a lowercase q. So this is the letter that you will see in equations to represent a charge. Now, charges can be separated but not created. And when we're dealing with the atoms, it's the electrons that can be removed from or added to atoms. And then the next topic is electrostatics, and that's going to be the study of electric charges that can be collected and held in one place. So if you think about static electricity, if you've ever been shocked, or maybe you've had your hair stand straight out on a cold, dry day, then that would fall under the category of electrostatics. For the microscopic view, you do not have to memorize any of these numbers. However, I would like for you to write them down in your notes so that when you go to do the quest problems or take your KIA quizzes, everything will be in one place. So if we think about the different parts of the atom, we have an electron, which obviously is negative. The actual value for the charge, and remember charge is a lowercase q when we get to our equations. For an electron, that charge is going to be negative 1.6 times 10 to the negative 19th coulombs. And you should recognize that 10 to the negative 19th means that that's going to be a really small number. For a proton, it has the same magnitude or size of charge. However, a proton now has a positive charge. And then a neutron isn't charged at all, so it's going to be 0. When we talk about the mass for each of these particles, hopefully you can see based on the exponent or power of 10 that the electron has the smallest mass out of the three. So the mass of an electron is 9.1 times 10 to the negative 31st kilograms, so it's really, really tiny. And then a proton and a neutron have the same mass as each other. Each of those are going to be 1.67 times 10 to the negative 27th kilograms. Again, you do not have to memorize any of these numbers. I just wanted everything collected in one place so it's easy for you to find when we go to do equations. And as far as the notation is concerned, these are just abbreviations, so you don't have to write out the words electron, proton, or neutron. So if you wanted to take note of any of those, you're welcome to use those as a shorthand. And then you should recognize that like charges are going to repel each other. So if I have, for example, two electrons, those are going to repel, and then opposite charges will attract. For example, an electron and a proton would be attracted to each other because they have opposite charges. The other part of today's lesson is to learn the difference between conductors and insulators. Conductors are materials that allow charges to move about easily. So for example, most metals are considered to be conductors. And when we get to talking about electricity and the flow of those charges, conductors allow those charges to move through, so your current or your electricity will be able to flow through them. Insulators, on the other hand, are going to do the opposite. These materials do not allow the charges to move very easily. So that means that those charges are going to stay in one place and they're not going to flow throughout a circuit. Some good examples would be plastic, glass, dry wood, or cloth. So these are types of insulators. Whenever we do have a charged object, there are two ways we can look at how something gets charged. The first one is called charging by conduction. And this is where we take a neutral body or some kind of object that's not charged in any way, and we touch it with something that is charged. So there's physically contact. So you can think conduction has contact. And those charges will actually transfer from one object to another. So I have a picture for you down here. So in this example, we have a metal sphere that has an excess of negative charges, and it's going to touch something that's not charged at all. Once they make contact, those electrons jump over and move to the object that was not charged. Now, when we take the metal object away, it has still an excess amount of charge, but not quite as much as it did before. And now both of the objects are going to have that negative charge because those charges jumped and transferred from one object to the other when they made contact. Our other option is called charging by induction, and sometimes you might see that referred to as the separation of charge. For charging by induction, we take an object that is charged and we bring it near something that's neutral or uncharged. And the charges in the neutral body are going to separate out. There's no contact. This is going to be the thing that distinguishes the induction from conduction. There's no contact, and the charges are not transferred. They're simply moved around within the object. So for our example, we can think about two metal spheres, and they each have an even number of positive and negative charges. Well, they're said to be neutral because they're the same amount of positive and negative. When we bring an object that's negatively charged over near one of those objects, you don't have to actually make contact. All of these charges that were on the inside are now going to separate. So since like charges repel, all of the negative charges that were in those spheres are going to move over to one side. And since opposites attract, all of the positive charges are going to separate over near that negatively charged object that we brought close by. So now that those charges have been separated, we can physically separate the two spheres, and then the excess of the positive charges would make one of them positively charged, and the other one would be negatively charged. So there was no contact needed. We just brought a charged object near something that was neutral and caused those charges to separate within that object. That's it for today. Next time we're going to learn about electric forces.